So we have some great talks, and it is my pleasure to present to you our first speaker in this block. Our first speaker, Gagik Arustamian, which will talk about developers tell about building an admin portal with GraphQL. So Gagik has over a decade in software development. He likes to learn new technologies and putting it to good use. He likes to share knowledge with people who he works with and share the same interest in technology. He spoke with a number of conferences and workshops, including JSConf Armenia and ReactConf Armenia. And I, for one, am very excited to hear the talk about GraphQL. So let's just put Gagik on stage. Hi, Gagik.
Hello. Welcome,
hi, how are
everyone.
You today?
Good, great. Very excited, actually. I've been waiting for this for quite a long time already.
Yeah, I think we all did.
Yeah.
So you're going to talk with us a little bit about GraphQL and how to actually build an admin portal with it. And I think without further ado, we can go to the presentation and maybe chat a little bit later. I remind you, folks, if you have questions, just write them in the chat. So Gagik, I'll add your presentation and take it away.
Guys, please attack me with questions. I'll be happy to share everything I know and everything me and my team had already built up experience with. So yeah, as Leah told, I'm a front-end developer. I'm actually lead front-end developer in an IT consulting company called SFL. And yeah, I have started my career back in 2008, those old and lonely days of Internet Explorer 6. Anyways, over the course of my career, I've managed to see some technologies progress and change, especially front-end technologies. And one area where I have seen a dramatic change is the area of how the client and the server exchange information with each other. And I'm not talking about communication channels like protocols, HTTP or whatever. I'm talking about actual content that goes back and forth. Yeah, and as the title suggests, we're going to eventually talk about GraphQL and how it works really briefly. However, this presentation is not actually a know-how of GraphQL and all of its details. If you are interested in learning GraphQL in its all details, there, I believe, good, very great talks coming up on GraphQL, and there are tons of documentation, resources, articles, and video courses that can teach you about GraphQL. But and yeah, we are going to talk about GraphQL as from the perspective of how we learned it. But this presentation is mostly concentrated around how we ended up needing GraphQL for our apps, a bit about GraphQL itself, how do we apply it in our project, and what do we expect going forward now that we have applied GraphQL. So it's going to be a lot of me talking. So let's start from a history and set a perspective on why did we end up considering GraphQL after all, and what promise did it have for us. So back in the days when I started doing web development, websites would mostly be rendered on a server, and PHP was arguably the most famous technology for doing so. And it looks something like this. So you would have a server, the browser would request to the server, backend would return an HTML document with everything already, as we say, pre-rendered in it. So the contents of the page, and the browser would display it. Backends in this case were these huge apps that had everything in one place, including data storage, business logic, as well as templating needed to produce the HTML pages. And in this case, of course, every click and every form submission would reload the page. It's obvious. Then we said, okay, this is not good. We want something better. What we want is for our pages to change only for our pages to change the portion that is updated actually. So if you refresh the page, the header does not need to change, only the contents of the page can change, or form can be submitted without reloading the whole page. And with this, a lot of technologies like AngularJS, which was the most famous one, came along and helped us solve this problem. But backends would, now backends, they transformed from providing us a complete pages. They transformed to only giving us APIs with everything needed for front end to make client-side updates. So with this, we entered the era of single page applications, which monolithic huge backends. And how it worked was, again, instead of like asking for the shopping basket page, we would ask for the shopping basket information, and we would use this information on the client to render the page. But then the backend guys were like, hey, this is not something we want the things to be done either. We want our backend not to be monolithic, but we want many tiny services, or as to say microservices, that each one concentrates on one specific business problem, the business domain. And instead of giving and directly talking to the front end or any being concerned about front end, they can just provide generic APIs the way they feel like they should provide the APIs, and whoever wants can talk through that APIs with them. And we were like, all right, so now we have SPAs, but on the back end we have microservices. And what it means is that now instead of getting all the data we need in a single request, we need to make multiple calls to backend. And those calls are not always running in parallel. And this is very important because sometimes you need to wait for one data to arrive to be able to decide what you need to decide, what you need to request for next. And in an example of a shopping basket, he would normally get the shopping basket which would have reference to different products that are in the shopping basket. Then you would get those references like product IDs, and then you would request product service for those products. So we're like, okay, but this is not working for us good either, because you can see how this can create performance bottlenecks. And now we're like, can't we just have a service that does this for us? Basically, we would request a service, and the service would do the combining for us. And we asked the backend guys to implement it for us. They were like, nope. And they were like, why don't you go ahead and implement it with your shiny Node.js? And we're like, all right, this sounds like an idea. Now, we not only will implement it ourselves, we will also come up with a nice acronym to name it, to be fancy, because we like acronyms. And we came up with BFFs, and BFFs stand for backend for frontend, not best friends forever. So we would make a single call to the BFF now, which in turn would make multiple calls to the microservices, which are super fast because it is a service-to-service communication, and get back the data that we need. In the beginning, it seemed like a very cool way to do stuff. But now, not only we had to maintain an additional service, but also almost every single front-end change required a change on our BFF. So, for example, if there was a new property that added by the backend, or the new entity, or a new action, or whatever it is, we would go and change the backend. And the little greedy front-end developer that sits in all of us was like, I wish there was a way to go back to doing nothing. And obviously there wasn't a way to do nothing, because we've already signed up doing Node.js in the first place. And we're like, okay, let's see what we can do. Because for now, at this point, we have already tried building our BFFs with the plethora of technologies. So we have first, in our specific example, me and my team tried it first with Express a few years ago. Then we were like, okay, this is total nightmare. We were like, okay, we should consider routing controllers. And routing controllers, if you're a TypeScript guy, is an extremely helpful library. If you guys don't know about it, go check out their GitHub. They're doing absolutely amazing job. And it's like kind of like Spring for Java, but for TypeScript. And so even if we were unhappy with this routing controllers thing, we could try other Node.js frameworks. But again, we would have the same fundamental problem. We are still building REST services again. So we're using REST services and providing REST service. And while we were busy with it, there was a lot of chatter around us about GraphQL. And when we looked a bit closer to what it does, it seemed like a thing we might consider. So could GraphQL be the next step in the evolution of the way we do front end? Well, here's a big spoiler for you guys. We still don't know, because we are still trying it out on large-scale projects, and we are still getting feedback and results from developers. But we did end up implementing it in many of our projects, and I will show you how it worked out in a bit. But the question still remains open to us, and it's still early to just pack all of our things and move to GraphQL forever. Now, as promised, a little bit of course on GraphQL and what is it. Very high level. I'm not going to go too much deep into details and provide like precise code samples, but just to give you an idea. Again, compared with conventional request response mechanism, you would, again, when you want to make a change to the data, you would go to your backend and you would create new endpoint or modify your new endpoint. And this is particularly painful when you want to combine different data like shopping basket and the products. So GraphQL, on the other hand, allows you to specify exactly what you want to get from your backend and magically add and remove any relations to other data. We'll get to that magic in a bit, but this already seems a great deal of improvement over conventional request and response. And before we will move forward, this is important to set this straight, is that GraphQL can be considered, speaking like not in technical right term, but in like amongst us, like GraphQL can be considered as this text, a specification that defines how do you write, how do you describe your data and describe your data graph, which is a fancy way of saying basically what you have and what you don't have and what can be queried. And besides that, GraphQL also is the service that reads this text and responds with the data that was requested to provide. Now let's look at how exactly does this magic work behind the scenes. First thing we need to do is describe what data do we have. In this particular example, we have a shopping basket, again, going back to that example, which has a property called total, which is of type float, which is, it has a decimal point, and it has a reference to products, which is an array of product. Then we would go ahead and describe the product. In this example, it would have, for example, an ID and a name. Now, next thing we need to do is define the schema. The schema is the definition of what is available for querying on the high level so that you want to let the public know about. In this particular case, we can query for all the products. Let's say there is a need for such functionality, which would return an array of products. And then we would have a query for shopping basket to get the contents of the shopping basket of the current user. And the same goes for mutations, because we don't only query, we also mutate some data. And this is just a affectionate way of saying data modifications, what used to be post and put request usually. Now we nicknamed them mutations. And to define mutations, we defined what can be mutated on the high level and what input is expected for that mutation. In this particular case, when we want to define a mutation for adding a product to the shopping basket, we say, okay, add to cart is available, but then to make it work, you need to provide the data, which needs to have the product ID, which is of type integer. So you can already see, I hope I could make that clear, that specifically if we're talking about admin dashboards, and admin dashboards mean tons and tons of data displays and tons of forms, this can be quite useful. This flexibility of that GraphQL brings can be quite useful. However, it is not all just shiny and bright benefits. Of course, this does not mean that whenever there is a new endpoint on the microservices side, on the backend of our backend, and if there is a new property that was added to the entities that we support, we can go around modifying our GraphQL server. We still have to modify GraphQL server. We still have to make changes. But what we can already stop doing is combine our data, like in the case of shopping basket and product, in any ways we want. And if products had references to other entities, we could as well also decide to query those. And okay, so far so good. There's also one more thing. If you're doing GraphQL, you need to keep in mind. I want to mention this briefly because this is very important, especially in GraphQL world, and it is caching. So what's happening is you have one endpoint now to query your data from, in contrast with your REST service where you had number of endpoints, each one with their preset data structure that can be queried. And what this means is that you cannot cache your GraphQL endpoints response, because then what would happen is that all the subsequent queries for different data will still get the previously cached data, which is a nightmare. You cannot let that happen. And so you kind of need to build a mechanism of caching, because you cannot not have caching at all as well. It's a huge performance bottleneck. And fortunately for us, there were technologies out there that wrapped GraphQL in a way that you don't have to worry about these things. And one technology that we in particular picked and were happy with was the Apollo. Okay. Now, just to be clear, Apollo does bring some benefits to us. In particular, Apollo has great server setup out of the box. So you can create your GraphQL servers with its toolset. It has amazing React integration. Happy us React developers. And if you later decide to rebuild your move to having, besides your React app, having like a mobile application in a native platform, Apollo has that also out of the box. It has Android and iOS clients. And then going back to the caching, Apollo does solve the caching problem, and it does it very eloquently. But I want to really mention this. Apollo was a choice for us. It was not the choice. And what I mean by that is that there are other great libraries that also kind of wrap GraphQL nicely and provide a lot of tools out of the box. So by no means I'm saying that you should go for Apollo, but you should definitely consider it. And by talking about Apollo, I just want to give you like a perspective of what it feels like working with such a tool. Now, let's see how it all ended up being, how it feels like kind of doing Apollo GraphQL in your React applications. So we still have to do, and in order to create the GraphQL server, we'll first talk about GraphQL server, we need to create our data graph. And we already talked about what data graph is. So you would define your graph, and then the next thing which you need to do is define resolvers. And resolvers are the thing that teach GraphQL on how to resolve your data, how to retrieve particular data, like in this case, how to retrieve a single product by its ID or list of products that you can see on the right presented. And the last piece that we need to define is our services. Well, you normally would have a number of those. And those are going to request your upstream API and pull the data in for the GraphQL server to consume. And this is quite an important one, because this is where we can avoid some unnecessary work or create performance bottlenecks if we're unlucky by doing like too many requests. In this case, in this particular example, let's say we're making a request for products to our upstream server. What this REST data source class, which comes out of the box with Apollo, does is it caches, it acts like a browser on your server end. It can cache the response of the server by looking at caching headers, just like a browser would. So far so good. And but even with such optimizations, there are still things that we need to consider. And what we need to consider is that there is something called a resolver chain. And you previously saw how I showed how we combine shopping basket with the products. But most probably the chain will not stop there, because for your products, you will most probably have another service, which is providing assets. And let's say your product has thumbnails, then you would go and fetch those assets. You would resolve a key, you would provide a key and expect a path to the URL of the storage where the file is stored to be able to display in the front end. So you can already see that the chain can become quite complicated, and we need tools to be able to trace what's happening on the back end, because we don't know in which ways our customers will eventually query our data. So we need to trace it, and hopefully, and unfortunately, Apollo also provides that out of the box. It's just a simple Boolean. You enable it and you're good to go. You have your tracing. And just to briefly mention, there is also something called Apollo Studio. They can consume this tracing information and provide like nice visualizations for you to see what's really happening on your production and see where you can optimize. Good. Now let's look at what's happening on the client side. As we've already said, Apollo has a pretty good React client library, and querying data from the server, if you're doing Apollo, will look something like this. So on the left, we defined our query. In this case, we're asking for the shopping basket. This is a standard way of defining GraphQL. So everything that goes inside template literal is a GraphQL spec, so to speak. And on the right, you can see how would it look like when getting the data from GraphQL backend. So you can see how nicely it is organized into our favorite hooks, and it helps us keep the code tidy. Now that we have this tool set at our disposal, we can go crazy with our data, and we can use as many queries as we want. For example, if there is a requirement to also display some country information for which we need the list of countries, we can simply append the countries query at the bottom of our existing query, and GraphQL server will happily respond with countries list as well. And if we want for like daily promotions on the bottom of our shopping basket page or whatever our use case is, we can add that as well. The same goes for mutations, very similar. It looks something like this. On the left, you again define the mutation you are going to perform and what you expect in response. Then on the right, you kind of warm up, I don't know how else to put this piece of code. You kind of warm up your mutation, you preset it, and then you can execute it at any event that you feel comfortable, like form submit or button click or whatever. So hopefully this was already a good high-level idea of what GraphQL is, what Apollo is, and what Apollo does, and how it looks like when you actually apply it to your projects. But let's remember that we're talking about admin dashboards, and we're talking about doing many, many data displays and doing many, many data manipulations. And when we continue doing this, and because we're doing a TypeScript project, we started pondering about the thing. And the thing was that we were doing, in fact, type redundancy. We had type redundancy, which means we were repeating basically the same thing. We were providing the same information. Let me explain what I mean. On the left, you can see a definition of a type. For example, we are defining our data graph. We say we have a product, it has ID and name. Then on the left, and then on the right, we have an interface that represents that, because it's a TypeScript code and we need to be able to work with our types and define, I don't know, signatures for our methods. But you can already see that they're not doing the same thing. They're not the same purpose, but they carry almost the same information. And same goes with mutations. You have GraphQL definition on the left, you have your TypeScript definition on the right, but this again feels like a repetition, and we don't like repetition. We know it's a bad thing to do. So on the client side, in contrast, we would have, again, we will define the queries. So kind of what are we going to ask our server to provide? And on the right, we have the TypeScript definition, because when the data arrives, we need to be able to work with that data in our components. So again, we are doing repetition. So this got us thinking about a way of combining these two in a way that we can write either one and not have to do the other, or the other can be automatically generated for us. And that will make us really, really happy. And because TypeScript in this case has more versatility, we said, why don't we go ahead and just make TypeScript generate the GraphQL needed to perform the queries. And we could do this, I know that TypeScript is compilation only, but actually there are APIs that help us tap into the typing process during the runtime even. For example, reflect metadata is an API that allows us to do that, and a lot of like Angular library also uses it heavily. And by having that, we could potentially make this happen. Especially when we're talking about admin dashboards, let's remember that we're talking about a lot of tables and a lot of forms. Normally what we would do is we would query the data, give it to our table, and give it the list of columns that there needs to be, and say, please display the data. And the same for form. We would query the form if there is pre-filled information, and define how we're going to send it to the server, and then by hand generate forms. So this was something that we saw, where we saw potential of GraphQL, like a potential to improve and make an awesome thing. So again, it's just an example. This is clearly hypothetical. I just want to bounce this idea off of you. We could just take this interface, if we decide to stick with an interface, add a couple of metadata using decorations, which are, again, heavily used by many different TypeScript libraries. For example, in this case, we could say, what is the query that can potentially return this product. We can give some table-specific metadata, and then we can help our application know how exactly to display our data. Because, for example, if we have a created, which is a string, you would most probably have an ISO string, but there's still a string. If you want it to be formatted in a way, you need to say that this is a data field. So this is how it could look like. The same goes with mutations and forms. And we spend a lot of time building forms, again, by hand. And but in this case, if we say that for add to cart, there is a need to have a product ID and an amount. And let's say it's not an action on the client side like a UI, but instead an admin form, an admin action, something you need to fill in and submit. Then we can say that here's the mutation for the add to cart. These fields are required, and amount field specifically has some validations attached to it. Then potentially, again, our application, we could have a library that generates a form provided this data. Now, as I said, again, this is totally hypothetical. We are still working on defining this because we still see a lot of potential. We have, I don't know, hundreds of forms and hundreds of tables in our particular admin dashboard that we're right now working on together with my team. And we see a lot of potential because this can save us a lot of time and a lot of resources and a lot of maintenance that is required, because we keep repeating those definitions all over our admin dashboard. And again, if you have ever came across to something like this, that someone does this. For example, I know that there are libraries that generate forms given the JSON schema. And there are also libraries that generate forms given the GraphQL type definition. Unfortunately, I didn't come across any library that does exactly this, what I described. But if you did, please hit me up. I'll be happy to learn and find out more about this topic. But besides that, I think this is all I had for today's presentation. Now, I want to thank you all for listening, and I want to wish you all to stay healthy.
Thank you so much, Gagi. That was a very informative talk about a topic that for me it's really interesting, I believe for everyone. I think I can speak for everyone when I say we were disappointed that BFF is not best friends forever, but backend for frontend.
Yeah, me as well.
Yeah, and I think we have a little bit more time. And since your talk touched all of the stages of implementing GraphQL with backend and frontend, I think we have some time for discussion. I remind
Sure,
you,
I'll be happy.
whoever is watching, you can write questions in the chat. And it was really a great talk. I see everyone writing it was a great talk, and we will have a Q&A session after the block, at the end of the block. In the meantime, I wanted to ask a few questions. First,
Sure.
is it possible to use it together with REST? So does it make sense to have some endpoints that would be GraphQL endpoints and some endpoints that would be REST endpoints? And how do you manage it in the server side?
Absolutely, and this is interesting because nearly every official and non-official documentation that I came across when I was learning GraphQL in the first place, they all stated that actually you can start gradually, which means you don't have to drop everything you have and just pack your things and move to GraphQL and then do a whole months-long refactoring. But instead, you can start small and you can mix and match. You can, for example, if you have a new endpoint coming up, you can just simply like implement it using GraphQL. And then you already saw, hopefully I managed to show you clearly like how do you request from your components to that data. So you can already see that you can easily combine use query with use whatever request method you prefer to fetch data from other data sources as well. It's just no problem.
Thanks. And regarding caching, that was the point that you referenced in the talk, and I think it's one of the, I won't say pain points, but it's one of the points that you need to consider when you work with GraphQL for the exact reasons that you mentioned. So by using Apollo, do you feel that when you're writing client code or client queries, you can not think about caching or performance? So do you feel that Apollo handles it well for you? You can just expand your queries however you want and have the peace of mind.
Thank you very much for asking this, is because I really wanted to cover this in my presentation and I thought it's going to just run out of time. But it's this nice opportunity to kind of a little bit elaborate on that. So let's talk about server and the client. Server, you need to have the proper caching headers in place for the REST data source, which I showed in my slides, for it to be able to do the proper caching. And this is very important. It will not just do out of the box because it does not know what needs to be cached and what does not to be cached. On the other hand, on the client, Apollo has this very nice caching mechanism, but it can be troublesome, especially with admin dashboards, because I'm pretty sure everyone knows this. You have a table, you click edit, you go edit one of the entities on the table, then you come back. What you expect is the table to be updated with the new information, right? If you have usernames, users table, you update one username, you come back, you expect the username to be changed. And this does not happen out of the box unless, I don't know, 7 planets line up in a row or whatever happens. But this just does not happen by itself. You need to make it happen. And there are multiple ways of happening. It's like the easy way and the hard way. The easy way, you can just say, you know what, Apollo, please refetch all of the user table contents. And of course, now that you have refetched, the new user information will be updated. But you can also go ahead and change this one particular user information in the cache. So Apollo provides access to the cache, and you can tap into it and then manually do the update after your mutation has run.
Great, thanks. And how do you combine it with client-side state management? For example, if you have some information or some data that should be saved locally or in memory, how do you combine it with GraphQL? Is it easy?
I have to be honest, this is another very good question, because I also wanted to cover that, and I knew there was not going to be enough time. So here's the funny thing we discovered when doing GraphQL. We just kind of started from scratch. We didn't just move gradually. We had an opportunity to start an application from scratch. And we said, okay, let's start. And then when we need it, we will add state management. They were like, okay, then the weeks passed by, and the need for state management never came, actually. It might have been our specific example, a couple of examples of an application of GraphQL in our company, but the need never came, because now you don't have to manage state, because you would keep the state with your API responses, for instance, as one, but now you don't have to, because you can requery, and the Apollo will know when to go for the server and when to return from your local cache, given that you have implemented your cache properly and you manage your cache properly.
Great. So maybe we have time for one question from the audience.
Sure.
Good. The question here was, is a GraphQL is only a solution for front-end back-end interaction, or would you recommend it as a good solution for between backends as a replacement for REST, for example?
Honestly, I don't feel myself very much qualified to answer that, because I didn't do that much of backend developer. I did some, but I didn't do much. But it is definitely a way to interact between backend services. And here's why. I've showed you very specific use case of GraphQL. I've showed you the BFF use case, where you mostly use it to combine data between that runs between your client and the microservices. But GraphQL is really very good when you even apply it to directly working with databases. For example, if your services is the endpoint, is the database, and is the persistence layer, you can still apply GraphQL. And I've heard there are libraries that kind of allow you to directly request to the database with GraphQL syntax. So you don't have to kind of write the logic of querying the database, then converting it into something that GraphQL can provide, but you can direct this communication between the client and the database, which is, I think, a very good perspective for GraphQL, and I'm personally looking forward to trying it out.
Great, thanks. Another maybe more general question that we have in the chat. So you talked about the benefits or advantages of GraphQL over REST. So when will you prefer to use REST over GraphQL? In what use cases you think that it's preferable to stick with REST or build a new REST API instead of GraphQL?
This is a very good question, and but this is still a type of question that goes, okay, Angular or React or this and that. As with all these types of questions, the answer is it all very much depends. Maybe after a couple of years, when we have run it, the GraphQL in general, for even more time, which will be twice as much as we did by now, we would have maybe more opinionated, point-by-point description. Why would you do that, and why would you do the other? But for now, unfortunately, I cannot really give like point-by-point clear examples of when would you use REST and when would you use GraphQL.
Great, and maybe you can talk a little bit about what does it mean to try and insert GraphQL into a company. So a company that already has a solution, that has a working product that works, and all of a sudden you think about putting new technology, especially one as GraphQL that maybe needs it has a little bit of a learning curve. So how was it for you? Who decided on it, and how did you implement it?
By answering this, I might also kind of scratch the surface of answering the previous question, because one of the points that considering one technology over the other is the people's factor, the team factor. In our case, we were all kind of had already some side knowledge of GraphQL. We have played around with it, and then we kind of gathered together and said, why not try it in one of our production apps. But if we were unaware of GraphQL in general, it would have been a problem, because then you have this learning curve, which is obviously a mindset shift kind of from REST to GraphQL. And then you not only have to learn GraphQL itself, but how do you use GraphQL in your, for example, with Apollo. Then you would come across caching issues, as I've described, and then you would resolve them and research how you do them. Well, it's not only that you have to learn GraphQL, you also think GraphQL. So in that sense, it is not that straightforward, I would say. It all depends on your team capacity and team knowledge skill set. For us, it was smooth because we already had the kind of air floating around of GraphQL in our office, so it was easy for us to pick that up and put it into action.
Cool, thanks. Thank you so much, Gagik. It was really interesting, very informative.
Thank you very much.
Great talk. Thank you so much. And Gagik will return for the Q&A session at the end of the blog.
Sure.